I welcome you all in this session. As you are aware, in previous session we were discussing about couple of questions related to hypothesis testing, and we have worked out couple of statements and we have seen some of them were true, some of them were false. Let us continue the same exercise. We will look at question number 25 once again. So, if we say that alpha is equal to 0.10 for a particular hypothesis which we are testing, what does it mean? What are we saying actually? Does it mean that the 10% is our minimum standard for acceptable probability? Does it mean that 10% is the risk we take of rejecting a hypothesis that is true? 10% is the risk we take of accepting a hypothesis that is false. A and B and A and C. So, A and C, which of these options are correct? Just think over this question for some time. So, alpha is given, right. So, what does alpha mean? Does it mean 10% is the risk we take of accepting a hypothesis that is false or hypothesis that is true? In fact, if you look at B and C option, in fact these two, only one of them can be correct, is not it? You can't have both these options correct. So, when you say A and C, it is possible that if C option is correct, then you might have a situation where A is also correct, then this would be the answer. And if let us say B is correct, then we do not know whether A is correct or not. So, if A and B both are correct, then this would be the answer. So, at this point in time, what is the correct answer for this particular question? So, if you look at this question carefully, alpha is nothing but type 1 error, it is the probability of rejecting a hypothesis when it is true, right. So, this B part is true, right, and when we say B part is true, it means this is true, means in D, if we take let us say D is correct, then B is there in D part, right. So, B is true, 10% is our minimum standard for acceptable probability. So, A is also true. So, the right answer is D for this particular question, right. There is no other answer except D, right. Let us look at one more slide on these questions. Suppose we wish to test whether a population mean is significantly larger or smaller than 10. Our population mean is significantly larger or smaller than 10. We take a sample and find sample mean as 8. What should our alternative hypothesis be? So, can you think of alternative hypothesis? Is significantly larger or smaller than 10. So, the alternative hypothesis would be what? Let us say if this is smaller than, right, then alternative hypothesis would be this, and if it is let us say larger, then again alternative hypothesis is this. So, B is the correct answer for this particular question, right. Suppose that a hypothesis test is being performed for a process in which a type 1 error will be very costly, but type 2 error will be relatively inexpensive and unimportant. Which of the following would be the best choice for alpha in this case? 0.01, 0.10, 0.25, 0.50, none of these. So, what is type 1 error? Probability of rejecting a null hypothesis when it is true, and we know that if we commit type 1 error, it is very costly. But if type 2 error is relatively inexpensive and unimportant, so what would be the choice of alpha in this case? Just can you Can you tell me what would be the right answer out of A, B, C, D, E? In fact, as in one of the previous examples here, what we have said, alpha is equal to 10, right, 10%, right, or is 0.10. So, what we have said that 10% is the risk we take of rejecting a hypothesis that is true, right. So, 10% is the risk we take of rejecting a hypothesis that is true. So, would you like this percentage to be more and more or less and less? You want this percent to be less and less, because you should not reject a null hypothesis when it is true. So, alpha has to be as low as possible out of these 4. So, the answer would be 0.01, right. So, the probability of rejecting null hypothesis when it is true is just 1% here in this case, is not it? Let us look at next question. You are performing a right tail test of a population mean and standard deviation is not known, right. So, this is you are performing a right tail test, right tail test, right. A sample of size 26 is taken and x bar sample mean and sample standard deviations are computed, okay, at a significance level of this 0.01. Where would you look at for t value in the t table? So, in fact, in different books you will have different ways of representing t values. So, whatever we have been following so far, you just look at the t table. At what degrees of freedom you should look at n minus 1, right. So, this is 26 minus 1, 25 degrees of freedom, right. So, you should look at the t value at 25 degrees of freedom, right, and whatever is that value, isn't that would be the right answer, okay. Let us look at the next question. When using the sample proportion p bar to test hypothesis where null hypothesis p is equal to ph naught and alternative hypothesis is not equal to, the standard error of sample proportion is what? Is it under root of pq by n, pq by n? Third option is under root of p h naught q h naught divided by n, p h naught q h naught divided by n, or none of these. So, in fact, this is quite a simple question, you need to just remember formula for this, right. So, C is the correct answer in this case, okay. Not much to think in this particular example. Let us look at the next question. For a particular hypothesis testing, alpha is this, beta is this. The power of this test is 0.15, 0.90, 0.85, 0.95, 0.25, none of these. For a particular hypothesis test, alpha this, beta this, what is the power of test? So, what is power of test first of all? Power of test is the probability of rejecting a null hypothesis when it is false, right. So, this is represented as 1 minus beta, is not it. So, beta is this 0.10. So, 1 minus 0.10 is 0.90 is the power of test. So, the correct answer is B, right. Let us look at the next question. For a two-tail test of hypothesis at alpha is equal to 0.10, right. So, it is a two-tail test, alpha is 0.10. The acceptance region is the entire region. The acceptance region is the entire region to the right of the negative critical value. In fact, let us first draw how the distribution would look like, right, for this question. So, it is a two-tail test, right. So, you have got two rejection regions. So, these are this rejection region, another rejection region. So, you have got these two rejection regions. and this alpha is 0.10. So, this is alpha by 2, right. So, it is 0.10 by 2 here and 0.10 by 2 here, right, and this is 0.90, is not it. So, the acceptance region is the entire region to the right of the negative critical value, this negative critical value, this, so sorry, this is positive critical value, this is negative critical value. So, to the right of the negative critical value, so A part is this the rejection region, or between two critical values, this one, between these two, right, this negative critical value, positive critical value and this region. Outside the two critical values, this side or this side, then to the left of the positive critical value, this is positive critical value and left is this, right. So, what would be the correct answer? The acceptance region is the entire region. What it would be? It's very simple. It is this region, right. It is between two critical values. In fact, we have said initially that when you said two-tailed test, it means there are two rejection regions, right, and the region which is not rejection region is the acceptance region. Okay. So, this is how you can solve question number 31. Let us look at next question. The normal distribution is the appropriate distribution to use in testing hypothesis about what? So, normal distribution is appropriate distribution to use in testing hypothesis about a proportion when n pH naught greater than 5 and n QH naught greater than 5. The second option is a mean when standard deviation is unknown and population is normal. So, under which of these situations normal distribution is appropriate, that is the question, right. A mean when standard deviation is unknown, but n is large, or all of the above. So, you have to find out answer to this question, and the question is when do we apply normal distribution, right. For application of normal distribution, you need to have all these conditions. So, all these are correct. So, answer is D. Okay. Let us look at next question. When a null hypothesis is accepted, it is possible that a correct decision has been made, a type 1 error has been made. What is type 1 error? The probability of rejecting a null hypothesis when it is true, right. So, here you are not rejecting, a null hypothesis is accepted, then it is possible that a correct decision has been made or type 1 error has been made, or both A and C have occurred. It means correct decision has been made and type 1 error has been made. This is the C part, right. D part, neither A nor B has occurred, none of these. So, what would be the right answer? When a null hypothesis is accepted, it is possible that then there is only one situation possible, which is A. This cannot happen because you have not rejected null hypothesis. Now, when B is not the answer, C cannot be answer because B is there, D cannot be answer because B is there. Of course, so the only possible answer left is a correct decision has been made, right. So, answer A is correct, or option A is correct in this case. Let us look at next question 34. When the null hypothesis is this, mean equal to 42, the alternative hypothesis can be, this is a very good question. So, it will help you in framing null and alternative hypothesis. So, when the null hypothesis is mean is equal to 42, the alternative hypothesis mean equal to 42 or greater than 42, less than 42, the second option. Third option is equal to 40, is not equal to 40. So, if you look at these options very carefully, how you can have 40 and 40 in alternative hypothesis. So, these two options are ruled out, is not it? Okay. Now, since you are saying that mean is equal to 42, and here one of the options is greater than or equal to 42. Since equal to is already here in this question, so this cannot be option. So, only option left is this. So, for 34, B is the right answer, mean is less than 42. Okay. Now, let us look at the next question. With a lower significance level, the probability of rejecting a null hypothesis that is actually true decreases, remains the same, increases, all of these. With a lower significance level, the probability of rejecting null hypothesis that is actually true decreases, right. So, A is the right answer. In fact, when you increase the significance level, let us say you test a hypothesis at 50% significance level, then there is a probability of rejecting null hypothesis when it is true, right. So, at lower significance level, this probability decreases, right. At high significance level, this probability increases, right. So, answer to 35th number question is A. Let us look at next question. Decision makers make decision on the appropriate significance level by examining the cost of what? Performing the test, type 1 error, type 2 error, A and B both, A and B both, A and C, B and C. Just think over it for a while and try to answer this question. And decision makers make decision on the appropriate significance level by examining the cost of, in fact, this will give you an idea, cost of what. So, when businessmen or decision makers incur cost, they incur cost not much while performing the test, but when there is type 1 error committed and type 2 error committed. So, they should minimize these errors. Okay. So, answer to this question would be B and C. Is there any option? Yes, B and C is the option. So, F is the right answer to this question. Let us look at next question. Observed mean value and critical Z values cannot be compared directly because since they are on two different what? Observed X values and critical Z values cannot be compared directly. Generally, what do we compare? We compare the calculated Z value with the critical values, is not it? So, in fact, you have got two types of scales. So, you can have one X scale is known as a raw scale, and the other one is Z scale, right. For Z scale, Z is equal to 0, right, mean is 0 and standard deviation is 1, is not it? That is what we have seen. So, they cannot be compared because they are on two different what? Scales. right. Let us look at the next question. In order to use the t distribution to test the hypothesis about population mean, we must assume the population is what distributed, this dash distributed, and this 10 and its standard deviation is what would be the, how would you fill in these two blanks? In order to use t distribution to test hypothesis about population mean, we must assume the population is what? Normally distributed or some non-normal distribution or what, and that standard deviation is what? Is normally distributed and standard deviation is unknown, right. So, it is unknown. So, for question number 38, this is, as I said, normally distributed and this is unknown, right. Standard deviation is unknown, but there is one more condition. The condition is that sample size has to be less than 30, right. 39. To be assured that a hypothesis test is working correctly, we would like the value of 1 minus beta. What is this called? This is called power of test, right. Probability of rejecting a null hypothesis when it is false, right. So, you should, what should be the ideal condition in hypothesis testing? You should always reject a null hypothesis which is false, right. So, that should be the goal, and which is known as power of test, or 1 minus beta, to be close to 1, right, as possible. Okay. Let us look at next question. Question number 40. The power of a test refers to the test's ability to dash the dash hypothesis when it is dash. Just think over it, it is not a simple question. The power of test, in fact, we just talked about power of test, refers to the ability to reject the null hypothesis when it is true or false. Tell me. The power of test refers to the test's ability to reject the null hypothesis when it is false, isn't it? So, this is how you should fill up the blanks, right. Let us look at question number 41. An assumption or speculation made about the value of a population parameter is what? An assumption or speculation made about the value of population parameter is what? It is null hypothesis, alternative hypothesis, or just a hypothesis. What would be the answer? It is just hypothesis, right. So, let us look at next question. Accepting a null hypothesis when it is false is a type error. Its probability is denoted by what? So, we have talked a lot about type 1 and type 2 error. I hope that you would be able to answer this particular question. Accepting a null hypothesis when it is false is type 1 or type 2 error? What is type 1 error? Type 1 error is rejecting a null hypothesis when it is true, but here we are accepting a null hypothesis when it is false, is a type 2 error. right, it is not type 1 error. Its probability is denoted by what? Its probability is denoted by what? Alpha or beta? Alpha is type 1 error, so this is beta, right. Let us look at next question. The assumption about a population parameter that we wish to test is dash hypothesis. The conclusion we accept when data fail to support this assumption is dash hypothesis. Just look at carefully. The assumption about a population parameter that we wish to test is what hypothesis? It is null or alternative? It is null hypothesis, right. The assumption about population parameter. The conclusion we accept when data fail to support this assumption is the alternative hypothesis, is not it? We also represent it by H1 or HA, is not it? Let us look at the next question. A hypothesis test involving two rejection region is called a two test. What? A two what? A two alpha test, to a beta test, or what? It is called tailed test, right. So, there would be two rejection regions, right. This one rejection region and this second rejection region, right. Let us look at the last one. If the null hypothesis is mean is equal to 10 and the alternative hypothesis is mu greater than 10, the appropriate test to use is what? So, let me draw this distribution. So, you have got mean over here 10 and this is your null hypothesis, this is your more than 10, right. So, this is your rejection area. So, this is a case of what type of tail? This is one tail test. So, you can write option over here is, let us say the appropriate test to use is one tail test, that can be one of the answers, or the more appropriate would be an upper tail test, right. An upper tail test or right tail test, is it? So, with this let me wind up today's session. Let me summarize what we have done in today's class. In today's session we have looked at couple of fundamentals of hypothesis, because by reading theory and by solving questions you do understand concepts, but by looking at all these 45 questions wherein there were questions on almost all the points related to hypothesis testing. So, we have worked out these 45 questions and I hope that these questions would have made your fundamentals bit clearer. So, with this let me finish today's session. In next session we will work out some questions on either two tail test using two samples or let us say one tail test using two samples, right. So, let us see what exactly we would be doing in next class. Thank you very much.